Hello everyone, I am Najme Nazari from the University of California, Davis. I am a member of ASIC Research Lab with the supervision of Dr. Human Humayun. This course development curriculum is funded by Intel Corporation. In this talk, I will be giving you how to use Quartus. This is the fifth video in a series of training modules that would explain how to design hardware accelerator using DPC++ on Intel DevCloud. This slide shows the outline of this talk. We will talk about FPGA structure, PLD design flow, and Quartus. Traditionally, there are two approaches to implement a design in hardware: ASIC implementation and FPGA. In ASIC approach, we can use standard libraries in order to reduce the area, increase the performance, and decrease the power consumption of the chip. However, it is costly if we don't want to the mass production. The other approaches is to implement our design on FPGA. By using off-the-shelf technology, we can decrease time to market and reduce the cost of development for low-volume production. It also provides the flexibility of reconfigurability. FPGA stands for Field Programmable Gate Array, and it is a configurable hardware that consists of adaptive logic module, memory blocks, and I/O block. It can be used in a system on chip and be connected to many peripherals and work with any other devices as an accelerator. The configurability comes from programmable interconnects and switches, and therefore, any hardware can be implemented using FPGA. Let's look at the traditional hardware design flow for FPGA. At first, the design specification should be given. Then we design the architecture and all blocks required for the design and their connection. After that, using any HDL language, we can write the code of the design. In this stage, we can verify the functionality of design using simulation. If the functionality of design is verified, we can perform optimization based on the target hardware platform. In the FPGA implementation, the last step is to perform placement and routing of design in FPGA. The netlist is the output of synthesis process. At this stage, we can verify the timing of design. If it passes the timing verification, we can port the design to the FPGA board. If we want to perform all of previous steps using Intel's based software, we can use the following approach. When we receive the design specification, we can do the manual design by using schematic or RTL. Then, the code written in VHDL Verilog can be used for the RTL simulation to verify the functionality of design. We can perform behavioral or structural simulation. The next step is synthesis, that we call it mapping in Intel terminology. It translates design into device-specific primitives. It also performs optimization to meet the area and performance constraint. The last step is to perform place and route, that we call it fitting in Intel. In this step, the tool maps primitive to a specific location inside the target technology and specifies routing resource to be used. The result is post-fit netlist. After that step, we can perform a static timing analysis to verify performance specifications were met. Then, we can program and test the design on board. Let's look deeper into the synthesis step. Synthesis translates HTL source file into an Atom netlist. Sources can be in VHDL, Verilog, or any other hardware design language. It will be converted to logic cell, flip-flops, I/O gates, memory blocks, arithmetic components, and wiring connections. Intel uses Intel Quartus tool for synthesis and fitting. This tool supports Intel family FPGAs such as Stratix, Aria, and Cyclone. Intel Quartus Prime is a design software that integrates all development steps in one tool. It performs logic synthesis, place and route, and device programming. It also includes model sim and supports RTL simulation. Everything required for a hardware design on Intel's FPGA is available in Intel Quartus Prime. In order to install and license your tool, please follow the instruction in the link that redirects you to the Intel's website. When the installation is done, open the tool. This slide shows the default window of the tool. In the next slide, you can see how to navigate in the tool. You can see main windows such as Task Window, Message Window, Project Navigator, and Tool View Window in this slide. You can see main windows such as Task Window, Message Window, Project Navigator, and Tool View Window in this slide. In the main toolbar, there are icons for quick access to main tools, as you can see in this slide. Window management is very easy in Quartus. You can change the location of each window and customize it for yourself. Tasks window enables easy access to most functions, and they are organized into related tasks within task flows. In Quartus, a project is a collection of related design files and libraries. At least one file must be selected as a top-level entity. A project can target a single device. You can create a project using Wizard window or by TCL script. In order to learn how to create a project in Quartus, please visit the link below. It answers most of the common questions during the project creation. Now, when you want to open the AES project, make sure that you select AES encryption as your top entity. I mean AES_ENC. You can analyze the design and perform the synthesis and fitting. After synthesis, if you open the technology map, you can see the schematic of design created by tool. By clicking on the chip planner, you can see how it maps the logics to the resources on the FPGA device. Eventually, you can see the report of fitter. It gives you all information regarding resource usage. Thank you for watching. I encourage you to follow up with other videos, and there will be also a GitHub repository that provides all the codes.